Hey, what is up guys, and welcome back. So in today's video is going to be a bit different than usual. Some of you might have noticed I haven't been uploading these past 2 months that often. Some of you might not have. And the reason for that is because I've been working on Meshflight. And you're like, what the hell is Meshflight? Well, first of all, let's discuss what is Meshflight. Well, Meshflight is going to be the AI that replaces your PID controller. Now, before we get into that, we have to talk about Neuroflight. So Neuroflight was the first one ever released. However, nobody really flew it except the creator, which is his name is Wil Koch. And a huge shout out to him for creating the environment and creating the stepping stones into helping somebody actually go and possibly continue and improve upon that work. And really big shout out to him. So let's discuss what is Neuroflight before we jump into Meshflight, and what are the problems I faced and how I have surpassed Wil Koch's research results, if you might say. So Neuroflight is basically Betaflight 3.3. And what it does is it removes the PID controller. Now, I'm just going to explain the PID controller as simple as possible. So you have a PID for each axis. So you have one for roll, one for pitch, one for yaw. Oh, there's yaw. And the PID controller outputs a number. So the PID controller for the roll axis outputs one number, which is negative 500 to 500. 0 being like this, 500 rolling this way, negative 500 rolling that way. And then the P does the same thing, and the yaw does the same thing. And those, when they're outputted into a mixer, which has nothing to do with the PID controller. And then the mixer mixes that information, those numbers, and creates your set point that you want to go to. So what the Neuroflight does is it removes that completely, and it gives the AI full control of the 4 motors. So there's no more mix. There's a small mixer that mixes in your throttle, but the AI, you tell the AI, it gets the error, like how much it's off its axis where it's supposed to be, and it goes there. So the AI controls the 4 motors, and that's what he's created. He's created the environment to train that. And I was also to replicate his exact work. Now there's a big problem with, I think I know the reason why he didn't release the firmware, maybe, I don't know. But I was able to replicate it to a specific extent. Maybe I'm 10 to 20% off. But the way that he's done it, the way that he ended up doing it, it seemed like he was short on time, maybe, I don't know. And but it still flew amazing. But the way he did it, he really crushed it down. Like he just, he took its full potential and crushed it down just to be able to slightly fly. And what do I mean by that? Well, first of all, let's talk about the environment where we're training, or the simulator that we're training the AI. It's basically a quadcopter, and you have access to the motors. The AI has access to the motors. However, the quadcopter is fixed on its center of mass. So it's like it's on a gimbal, basically. And when you do that and you start training, now the AI doesn't know oscillating is bad. It doesn't know that going full throttle is bad when you don't need it. Because if you're on a gimbal, you could have all the motors full throttle and it'll still stay at 0 set point. And if you wanted it to roll, it could keep them all at 100 and decrease these by 5%. And then there you go. Because it's much easier for it to know that because it's just constantly going up and down, the probability of it having all of them full throttle to hold its position when you have the set point to 0, which is just flat, is more likely, and that's what it tends to learn. So Wil Koch implemented a reward. It's a negative reward. Basically, the AI learns by rewards. It just needs to maximize this reward, and usually it should theoretically be more dynamic, and you shouldn't mix more than one reward in. So you have to be very clever and very creative. So he introduced, we have 2 separate rewards. We have one for the error, which is how far it's off, which was also a negative. And he had another 2 that were negatives, which is a do nothing reward, because it ended up doing nothing because of another negative reward, which is minimizing control output, which means minimize or stop using so much throttle. You're not supposed to do that. So that reward kept kicking in from the beginning. That's the one that's just kicking right in because the simulator starts at 0. So the error hasn't kicked in yet. Or it does kick in when it's doing some weird stuff, but more likely you have the reducing control output kicking in always. And what that tends to do is that you leave it training for like 8 hours and it'll basically learn to do nothing but turn off the motors and stay still, which is bad. So it finds out that it could get the most amount of rewards by the end of the episode. We call it one full simulation is about 4 seconds, 4 theoretical seconds. And it finds out it gets the most reward if it just turns them off and stays still. So that was one big problem. So that's why he implemented the do nothing reward, which was huge, like humongous. You have to scale these very, very precisely. You know, just like a couple 0.5 off could completely change the result, which is insane. So you fine tuning these is an absolute nightmare. We'll get into more of that. So he implemented the do nothing reward. And that could kind of go into chaos and just keep it flipping and rolling, basically. And just like keeping two motors on, and it's not, you know, caring about the set point. So yeah, that was it. And then he had another one, which was a positive reward. Once you're within a specific, you know, if you're 10% within the set point, then it starts giving you a reward based on how low you're using throttle, which worked. Now, when you mix these up together, it's just so aggressive, and it ends up what ends up doing is it squashing your motor's output to like between like it was like 2.5% and 10%, but also oscillating. But on a low power quad, you won't notice that, but it basically hindered its full performance. Like it's sluggish, and you kick it in the face, it'll go off flying, and it was very sluggish. So obviously these AIs could do way, way more. And it turns out this is actually a very simple problem. But I mean, after you do a lot of work compared to the other stuff, like playing a video game, this is much more simple than playing a video game, actually. But you have to know quite a lot in order to get to that stage. So I was able to replicate it, and that's what I got. It flew amazing, and great job, Wil Koch. I'm not putting anything down. I'm very grateful for basically you've cut the work in years for me in order to use that simulator, and that's it. I just completely modified everything, by the way, but it was a good starting stone for anyone who wants to try it out. It's Neuroflight. I'll have it linked down below. Also, the environment is called GymFC. So huge shout out to Will. He also has his channel. He also shows you how to install it recently, so you go ahead and check that out. And maybe later on I could do more videos on this on my other channel, or maybe here. So now let's talk about Meshflight. So Meshflight ended up taking two routes. So we talked about how the PID controller can output between 500 to -500 for each axis. So, and then it goes into the mixer. So this interface where the PID controller puts those numbers, I remove the PID controller and I put the AI to input just between -500 and 500 for each axis. And what the benefits of this way is that you'll be able to use it on just about any quadcopter, whether it's a tricopter, whether it's a whatever copter, because then that's it. It'll go into a mixer because it's just talking to the mixer interface, and you could use whatever mixer you want down there. Theoretically, it should work pretty good on any quadcopter. However, training that is an absolute nightmare. It is a nightmare to get right. But I did get a good result, flyable result, but I don't like the end result, which is why I put it to the side and I went back to the original Neuroflight implementation, but with a lot of modifications, which is just the AI controls the 4 motors. So basically you're limited to a quadcopter, which is 4 motors. So now comes the time where I have to redo the whole reward system, and we're not going to talk about redoing the whole simulator, like how random it be and stuff like that, because we did run into problems because of that, because the original implementation was it waits half a second, and then it has the rest, which was 3.5 seconds, or maybe a little bit more than that, actually 4 seconds, and it gets a set point exactly for each axis. So it doesn't get, oh, just roll. No, it gets roll, yaw, and pitch at the same time. And the problem with that is sometimes when you want to go roll, because you're doing that, you're doing all these 3 at once, it actually tries to roll with 1 motor sometimes, and it does some weird stuff. So we had to redo that. But we're not going to get too far into that. So I've redone all of that. I'm still perfecting it. It's still not perfect, but it's still good. It's good enough now. So now let's come to the reward system. So I've completely remodified it. I've kept his base error reward, but I've completely rescaled it, which really means rescaled the size. It used to be like the error. So if the error for each axis, so how far it's off by degrees, added all together, and then to the second power, I think it was, to the second power, which was huge. It was a huge negative reward. But it also gave a positive when you went to go, when you're getting closer, it started giving a positive. But the problem with that positive section, the way that it was doing it, is pretty bad, because when the AI gets to a specific point after you have everything correct, that little positive, because the AI loves to cheat, by the way. It's called reward hacking because they get so good or they figure out bugs in your reward. It kept wanting to do this. Yeah, it kept wanting to do that because I could see the reward. I was graphing the reward. I was this oscillation, well, this type of oscillation, not the motor oscillation, but the oscillation for the set point was due because it was trying to maximize that right there. So I had to cut that off. I had to cut. If you're over 0, boom, you're 0. That's it. Figure it out on your own. So it can't go over 0. So I left a negative just for it to learn its set point. So that when you watch the simulator, that's the first thing it learns. So then comes the next step, which is reducing control output and oscillations. Now, reducing oscillations is my secret right now. I don't know if I want to release that, but we're going to talk a little bit about the reducing the motor control output here. So we had one implementation, which was once you're within like 5 degrees of each axis, so you're within a good set point. So yeah, you're actually holding the correct way. Then the more you decrease it, the more points you get. It worked, but to a certain extent. It worked to an extent, which is the video you're going to see flying. The recent ones I haven't flown yet. I've flown inside and beautiful, but there's still a problem, which I'll explain. It's not a problem, but I'll explain that in a bit here. So the problem with that reward, where when it's within its set point to start reducing, was it won't reduce for so far, and I had to train it for like 15 hours, and like every 2 hours it'll drop like a 2%, and it'll always stay between oscillating basically, or it'll always keep its output oscillating at 20%ish, 0 to 20%. So holding its set point 0 to 20%, and then if it wants to roll, it goes crazy, and then it just, you know, it was doing this. It was doing like this pulsing. It was really weird. Anyways, but I was able to kind of cheat in a way, which was its output. What I did was inside the Betaflight source code. So you know how we have the oscillating 25%. What I did is I just took 50% of whatever it was outputting and stuck it inside Betaflight, and that reduced the oscillations, and that's what you saw and what you're going to see in that video. It worked. It works. It just proved to me that everything works. So that's a really good step. Now comes the new step, which is really insane. So this one is more dynamic, and I had to go through a ton of black box logs, like a ton of black box logs. And I figured out a pattern in the way that the motors are actually, what they're doing with the current set point you're supposed to go to. Now I'm able to train it in 3 hours, sometimes even in an hour. I could literally train it in half an hour. But again, I bought a huge ass PC to do that as well, so not everybody's gonna be able to do that. I got a 3950X AMD, and I'm able to run 16 simulators at one time, and that cuts down like quite dramatically actually. I could even optimize more, but I don't want to waste so much time on that. We'll get into that later on. So the way that I was able to do was able to average everything out in a specific ratio. Now I'm not going to discuss the ratio because at the time it's still, I'm just keeping that secret to myself because I worked so hard for it. And once I feel like releasing it, then I'll release it. So I figured out that if I take the average of each set point, so for example, it had to roll, yaw, and pitch 100 degrees at the same time, just theoretical. So that's 100 plus 100 plus 100. Divide that by 3, you get 100 because that's the average. So the average is 100 because obviously all of them were 100. And then I was able to divide that by a specific ratio to get a specific throttle usage, and then implement the throttle usage to be an average. But there is still a slight problem with the way that's implemented, which is because the lower you use, the more reward you get. But you don't want to keep putting static points for everything, because obviously one thing, every quadcopter is different. Another thing is, you know, you're just limiting it. You're limiting its true potential. But it got it to a good point, plus my little secret behind for oscillations really helped that out. But it's still oscillating, but not to a point where it does anything to the quadcopter. Actually, the motors come down cooler than the PID controller, which is really nice. So now it's beautiful. But actually, it flies as good as a decent tuned PID controller that has no I term. Now you're like, what the hell does that have to do with anything? Well, what I've learned is, let's just think of, you know how PID, you have the I. Now the I kind of helps you with external forces. So if it's nose heavy and it constantly wants to dip, it's kind of like a history state. So it remembers where it was, because the gyro keeps resetting, by the way, and I'll explain that in a bit. And it wants to and then the I term helps it comes back. And when you hover a PID controller, just hover it, you'll find it pretty damn stable if you have a decently tuned PID controller. Really stable. You'll find it really stable. And if you hold it and you move like this, you'll feel it constantly fighting you to come back to where it was. Now, if you remove the I and you put it to 0, if you do this, it'll try to fight back as you go along. But every time you stop, then basically, oh, you're stopped. It doesn't remember that it was all the way up here. So there is no history state in a way. And you can actually go test that right now. I don't recommend you do it this way, but just make your quadcopter nose heavy and remove the eye on the pitch, for example, and watch it just constantly dipping like that. And that's what's going on. So right now I need to implement some sort of a I term history state. I wrote that guy UAV Tech, but he's not answering me. I don't know why. Maybe he doesn't like me. I don't know. I've never talked to him before though. So he's kind of one of the devs on Betafall. I don't know how big of a dev he is, but he's one of the devs. And yeah, but I don't think he's gonna respond. So right now I'm working on it. I've already done a quick test and it seems to be pretty good. But it still needs obviously more work. So that's where we are right now. And you know, the second step would be doing that PID control or something, but we'll come back to that later. I don't want to lose you guys. So right now I'm in a really good position. Like if you fly, you won't really notice it, but you kind of will, but you really won't notice it. And it's really good. I've tested from this weird ass creation to a really high KV one to some 6S setups. And it does. I've even tested micros, the tiny micros, like the super tiny 1S micros, and I've tested the Emax Tiny Hawk on it. I put the AI in just about everything to see how it does. It does pretty good. But all I have to do now is figure out the I term. Now, if any of my Patreons want to have has a Kakute, because that's where I'm releasing it first at, I could actually compile this on anything if I wanted to. F7s and F4s. I could even run it on Arduinos probably. That's how small I've made it. So let's go ahead and take a look at some of the footage. Now remember, this is not the final version after the latest updates. This was the one where we were just implementing that 15-hour one. There were still that oscillations, and then I had to cut the throttle by half or cut the output by half. And you can see how it flies. Now remember, there's also something really important in this. Air mode is not active. So when you see me drop the throttle and it goes like this, well, that's what would happen with a PID control if you have air mode off. That's what air mode does. It just kicks in and it holds it into place. So it doesn't have air mode in that one. It doesn't have any sort of air mode implemented. So if you reduce the throttle, you ain't got nothing to work with really. You're just gonna fall down. So you had to keep the throttle up. I don't know. Some of you are old here, so some of you will remember the days without air mode. And yeah, but we'll come back to that later on. So yeah, don't think that those dips are because of it. No, it's because I dropped the throttle, because obviously I'm used to air mode. So dropping the throttle, rolling, I expect it to roll. But obviously in that one, it wasn't the case. So, but in the newer ones, it is the case. Air mode is slightly implemented, but I've limited it to a specific extent because I don't want anything going crazy, because I don't want to give the AI full control of the full range of the motors. I've limited it to around 64%, which is still quite a lot, but I actually trust it. It's crazy. I don't trust PID controllers more than I trust my AIs for some reason, and I don't trust quadcopters. So that's a big thing for me. So yeah, let's go ahead and take a look at the flight footage. All right, guys. So now we're looking at the second version before the new implementation of the oscillation. I still haven't flown that outside, but you'll get to see that soon. So I do have the HD footage. This is a high KV 4S setup right here. This one right here, it's a Vanta frame. I'll have a video on that later on where you can see it. So let's go ahead and see how this. So this one again, it has the oscillations, but then I cheated, like I mentioned before, by limiting its output by 50%. So if it was outputting 20%, then it'll output half of that. So that's 10%. So that's what I did here, and that's what you're gonna see. This is before the latest implementations of the new rewards, which are insane. And again, yeah, just go ahead and take a look at this. So there you go. You could kind of hear that oscillation, especially in the high KV. You could also see that. So that little dip is because there's no air mode when I drop the throttle. And you can tell that I'm just taking it easy. I'm trying to see what it's going to do. It's not going to be a super freestyle flight. It's just a test flight here. So I'm just trying to see what it wants to do. External forces do play upon it, like I mentioned earlier, about kind of like the I term, which is kind of like a history state in a way. So here I'm still dropping the throttle. This was the first flight because obviously there's no air mode. So if you fly a PID controller with no I and no air mode, this is how it would be. But as you can tell, it's absolutely responding to what I'm telling it to do. Now the response time is, I think on this one was 0.1 of a second when I tell it to do something. or when I tell it to do a hard roll. It reacts almost immediately, but it gets there if it's at 250 degrees. There we go. So here again, I'm just flying it. Now, the wobble, I don't know what it's from. Maybe the mount on this frame, because this is the first time I just built this for this, so I have no idea how it performs regularly. I was using a run cam also for this, so just in case if it breaks or just takes off. So here I'm just seeing how well it's holding its set point if I'm constantly moving. You see we had a little bit of bounce backs, and those were apparent. This is the older version again. This is not the latest one. Here I'm trying to do punch outs. You can see how when you punch out with low I, how it kind of just drifts off. That's exactly what I was talking about. And yeah, so. But it was absolutely responding to everything. It didn't do anything weird at any single time. You can see when you give it more throttle, the oscillations become a bit more apparent. Maybe because I used fold props also, I don't know. You can see how it's not locked in, it feels loose. And again, that's because of kind of like what the I term does in a PID controller, where I need to implement that into the AI. Again, like a history previous state. So there it did something kind of weird. But I think I dropped the throttle. I don't really remember there. And yeah, that was the AI for you. And yeah, if you guys like this, let me know down in the comment section. That would mean so much to me. And also have links to the builds down below. And if you could click those again, those help support the channel. And come join my Patreon so you get exclusive access to the AI firmware. And I'm planning on making a Discord where you guys could share what's up, what's going on, or your testing results and what needs to be improved and whatnot. So I really hope you guys enjoyed the video. Let me know what you think down in the comment section, and I'll see you guys in the next one. Peace out.